When a lap belt is used to install any CSRS, the seatbelt system locks at the latch plate. A locking bar on the latch plate will hold the CSRS tight, even under the force of a crash. In fact, when any pressure or force is placed on a lap belt in its locked position, when the webbing lies flat, the belt will pull the locking mechanism even tighter. All lap belts work on this principle, but the design of this sample latch plate makes it easy to see how this bar slides to lock the belt. Locking latch plates can loosen when they're tilted into an unlocked position, as shown. Because the webbing does not come together as it wraps around the locking bar, it slides freely, so you can lengthen it. But note that if a lap belt's latch plate is in this position after it's been tightened to install a CSRS, the seatbelt would not be locked at a fixed length. Therefore, whenever you've completed installation of a CSRS using a lap belt, always check the latch plate to ensure it has ended up in a locked position. To test this, apply what you've learned about how the webbing must wrap around the latch plate to be in a locked position. Is there a gap between the two segments of the webbing, in a position that allows the belt to lengthen? Remember, this is an unlocked position. Or does the webbing lay flat next to the latch plate, wrapping around the locking bar properly to stay locked? If it's not possible to tell by looking at or feeling the webbing at the latch plate, another test is to push and pull hard on the CSRS. If the webbing lengthens at all when pushed hard in this way, the seatbelt system is not locked and the installation is not safe. The problem itself is caused by where the buckle places the latch plate with respect to the particular CSRS being used. When this is a problem, here are some solutions to try. You can try another sitting position instead, but if you need to make this position work, you'll have to correct the problem. A different CSRS with a different belt path may not have this problem. If this isn't possible, you can try making any of 3 adjustments to the seat belt. Sometimes pre-shortening the lap belt and then buckling it after flipping the latch plate over, putting a half twist in the webbing, can solve the problem. While this puts the latch plate into a locked position, sometimes the seatbelt cannot be buckled this way, or the CSRS installation cannot be properly tightened. So another option is to try using the twisting method to shorten the length of webbing that's attached to the buckle. Each twist in the webbing moves the position of the buckle lower, so the latch plate will have more space to reach a position in which the webbing will be locked. Up to 3 full twists are allowed, and only full twists should be used so that the buckle's button always faces away from the CSRS. However, while the twisting and flipping methods tend to work well in many passenger vehicles, when buckle webbing is very long, more than 4 or 5 inches, as is often the case in school buses made prior to October 2011, these methods are not effective. Instead, a school bus mechanic should be asked to upgrade the seatbelt system using an approved FMVSS 209 replacement that has a shorter length of webbing to anchor the seatbelt buckle to the bus seat frame. When the buckle webbing extends only an inch or 2 from the bus seat bite, the problem of an unlocked lap belt is far less likely to occur.